All right, welcome everybody to our Let's Talk Meshing live Q&A session with the Pointwise product planning team. My name is Travis Kerrigan and I'm the manager of business development here. And I'm joined today by Carolyn Weber, our engineering services manager, and Mike Jeffries, our product development manager. And today we're here to answer any questions you may have about Pointwise the product, our latest feature set in version 18.4. We just had our 5 days of Pointwise. This is the last day of that series of events. So if you've watched any of those videos and you've thought of any questions, now's a great time to ask. You can also ask questions about our product development plans or really anything else mesh generation related. I am going to start off with a question to our audience. Can you all see the three of us? Carolyn, Mike, and myself. You can type that into the, all right, we got an answer. Yes, good. I'm glad to hear that. So that's good because those answers are coming in via the questions dialog box. So that's where you'll be able to ask your mesh generation questions. Go ahead and just type them into the questions dialog box and we will go ahead and get to them at this time. So with that, we already have a question. The first question we have, which is a good one given everything that we've been talking about this week, is why the name Flashpoint? So I'm going to pass that one off to Carolyn.
Okay, that's a great question. I have a relatively quick answer. Flashpoint, when we got to thinking about what to call this suite of features, Flashpoint seemed like it really fit the bill because Flashpoint means it's a point at which something suddenly bursts into action, into being. And for us, we felt that was really synonymous with fast and automatic meshing.
All right. Okay, question number 2. What is the difference between the existing surface meshing tools in Pointwise and Flashpoint surface meshing? That's a really good question. I'll go ahead and take that one. So the existing surface meshing tools in Pointwise and just Pointwise's meshing paradigm in general is bottom up. So we have a bottom up meshing process where you start the geometry, build grid curves, surface mesh entities, what we call domains, your blocks or volume meshes, and then export. And that's kind of our standard surface meshing process. And we've started injecting some top-down techniques like domains on database entities, a really quick way to just get surface mesh entities on top of your geometry, which creates not only the surface mesh entities, but also the grid curves or connectors. Things like applying anisotropic stretching and synchronizing spacings at nodes, all of these are kind of top-down tools that we've started developing over the last couple of years. Flashpoint, on the other hand, is truly top-down. It takes our best practices and really wraps them into kind of a push-button top-down workflow where you just specify your meshing goals and you get a consistent set of meshes that follow the exact same rule set each time that you use it. And that's the real difference. So, standard surface meshing, bottom up, Flashpoint surface meshing, top down. But one of the real benefits is that these things can interact with each other. So if you make a surface mesh using Flashpoint's top down workflow, you can interact with that mesh using all of the existing bottom up meshing tools for really kind of the ultimate bit of control over your meshing process. Good question. All right, the next question. I generate meshes for several application areas at my company. How can I tailor Flashpoint to each application? Is there a set of parameters that you would recommend? And Carolyn, you're muted.
Sorry about that. Yeah, I'll answer that one. No problem. So first off, because of the way we've designed Flashpoint, it's really easy to save a recipe for your best practices for a particular application area, right? And you can reuse that recipe. It's essentially just a file that you save out, and you can reuse that for future versions of that geometry, say parametric variations, or if you have other geometries that you need to mesh that are very similar in nature. Now, the current default parameters generate very high quality surface meshes for many external flow type application areas. And we focus on giving you automatic anisotropic stretching in areas of high curvature or areas where there are convex feature edges. I would use those out-of-the-box settings with Flashpoint to get started if that's what you're doing. Now, if you are working on more of an internal flow type situation, or maybe generating surface meshes for FEA analysis, I would simply turn off that anisotropic stretching control for convex feature edges, and then use the remainder of the out-of-the-box settings.
Okay. All right, the questions are rolling in, so that's good. All right, next question. What other features are being developed under Flashpoint? This is a really good question, and in fact, there's several questions that point to this specifically. So Flashpoint is really just a suite of features that's being developed to improve automation in Pointwise. And Flashpoint for surface meshing was the first to be released, under that umbrella. The next thing that you can expect is automatic volume mesh assembly. In fact, Carolyn is working on the requirements for that feature as we speak. We've been having a lot of discussions about that recently. So that would be the next step in kind of the Flashpoint feature set. The next would be automating the geometry preparation process. And we're having conversations with our clients to really identify where's the bottleneck in the geometry preparation process so that we can focus on the right aspect of that in terms of automation. And that's kind of where Flashpoint is headed kind of in the near to medium term. But one of the things that I also wanted to kind of point out with this question is that we do have 3 focus areas for development, and Flashpoint really is the automation focus, right? The other 2 are acceleration and innovation. So on the acceleration side, in Pointwise version 18.3, we multi-threaded surface meshing, so it's 4 to 5 times faster, generating unstructured surface meshes on your geometries. We're currently working on multi-threading TRex for our boundary layer meshing. It's already very quick, but we're working at making it even faster. And our latest high order work that just completed, we found that the degree elevation process needed a bit more work in terms of performance, improving performance. And so the performance of degree elevation in particular has significantly improved in that version of the code. On the innovation side of things, we have some vertex-centered metrics that we've implemented in Pointwise. As you know, Pointwise kind of being a general purpose meshing tool for CFD, we can make meshes for cell-centered codes or node-centered codes. So now we can examine the metrics for both types of codes. Solver independent grid adaptation falls under the innovation category. We're doing a lot there. High order meshing, I've already mentioned that. Things that we're looking at are unstructured volume mesh smoothing, surface meshing, quality optimization, and even some poly meshing. And Mike may get to talk a little bit more about that here soon. All right, so let's see what other questions we have. All right, next question is, how friendly is the new feature Flashpoint with STLs? That's a really good question. I'll go ahead and take that. So right now, the prerequisite for Flashpoint is a watertight and quilted model. In Pointwise, an STL is not a model. It's considered what we call a shell. And a shell is a faceted collection of triangles or quads, if you will. And not all of our existing geometry tool set work with STLs at this point in time. So right now, the prerequisite is watertight quilted model. It's not really going to work for STLs. So that's a really good question, and I'm glad that I had an opportunity to kind of clarify that, because I know that's come up a couple of times. All right, the next question. This is a good one. Why is it important to diagonalize the structured mesh? If you shoot for quad dominant, is this even necessary? Do one of you want to take this one?
I'll hop in there.
Sure, go ahead.
Okay, so in the past, we recommended that you diagonalized these trailing edge domains when you were making, say, prism tap meshes, right? And that was simply so you would have some consistency kind of marching around that trailing edge. And also when you have a structured domain there, those cells in a typical IJ type Cartesian space, they're in a locked type state. So if we are marching off those cells with our extrusion algorithm and there isn't a quality issue with the resulting stack of cells, we can't really change that surface cell if we need to, say diagonalize it, because there, for all we know, that structured surface mesh domain, there could be a block on the other side. We really treat structured meshes as kind of sacred in Pointwise. However, that was years ago. And in the last few years, we've made some changes to our feature set and we've added some capabilities. And now my best practice when I'm making my meshes is I typically make them quad dominant. And then on those trailing edge domains, I can start off with structured, and there's a feature in the Create Diagonalize menu called Keep Quads. And you can check that on, and what it will do is it will turn those into unstructured quads. So as our extrusion algorithm marches off those unstructured quads, if there's a quality issue with the resulting hex stack off of those that we think would cause an issue with your solver, we can decompose that hex stack into stacks of prisms, and we can diagonalize that single quad on that domain and give you a much higher quality mesh in the end. Another great new feature that goes along with Keep Quads that you should be aware of is the replace option. This allows the original domain that you had in that block definition, when you use Keep Quads to make them unstructured quads, it automatically swaps that domain out in your unstructured block so you don't have to rebuild it.
All right, thank you. All right, Mike, I've got some questions for you now. The first one, because I alluded to it earlier and it has come up a couple of times in the list, Polyhedra. What are we doing currently to support Polyhedra?
So currently we are working on changing, extending some of our low-level data structures so that we support 2D polygon elements and 3D polyhedrons. And that is, kind of the first step that needs to be taken, and we are currently working on it now. Once that is complete, we'll need to start extending support for these elements to other parts of the code, things like examine, being able to export them. And so that all needs to happen before we fully support polyhedrons in the application. But we are currently working on the first step.
Okay. Another question, and Carolyn or Mike, either one of you could answer this because I know that you're both working on it, which is, when will Flashpoint for volume meshing be available? And maybe in particular, what version might we see that?
I'll take it. We are planning on having Flashpoint for volume meshing in the next major, minor version of Pointwise, which is 18.5. So it is the next feature release version that we will release.
Okay, excellent.
Sometime next year.
Okay. Carolyn, here's a good one, because you and I have been talking about this a lot in meetings with some of our clients. Can you give us an overview about the plan? Well, here's the question is, can you give us an overview about the next plan for automation on the CAD side? And maybe you could expand upon that a little bit, Carolyn, by talking about the two questions we've been asking our clients.
Okay, so this is sorry, this is one of the many things I love to talk about related to mesh generation. So the way I see it, and I think Travis is in agreement, is when it comes to making geometry preparation for meshing easier, there are really two pathways that we see classes of people going down in our community. So I'm going to talk about the first one, which is you get some CAD file, and maybe you don't have access to the original CAD package or designer that CAD file came from. And there are issues. Maybe it was an IGES or a step file, and it went through multiple format changes, and there's a lot of translation errors in the file, gaps, overlaps, missing surfaces. In those cases, most of those people, and this is a good percentage of our community, so far I've seen this like 50%, in those cases, those people have to have some mechanism to clean up those problems. It may be they need to replace the surface, or they need to close up gaps that came from translation errors, or something else. Maybe there's a surface where there's a parameterization that is a problem. In those cases, there need to be tool sets available for those people to do the work they need to get that geometry to a watertight state, right? So we can go further down the road towards meshing. And we already have a feature set of tools in Pointwise you can use to do this, but going forward into the future, we are really actively right now talking with our clients and asking a lot of questions related to what else could we add to that feature set that would make your life a lot easier when you're in this situation, right? Where are some holes that we could help you out? So that's one pathway. You know, how do we make cleaning up geometry and getting it to a watertight state easier for you so you're not spending so many cycles in that part of the process? The second pathway is the other half of our customers. Maybe they have a really great in-house set of CAD designers, and they've got maybe a really well-defined set of best practices, or just whoever they get their geometry from. It's really good, clean geometry. So for those folks, they don't have that cleanup issue there. For them, they want to be able to get to their engineering topology. In other words, I want to map out on my geometry exactly what I want the surface mesh to look like. And I want to do it really quickly. So we already have tools for doing this in Pointwise as well. It's part of our solid modeling suite of tools, where you can create a solid model, which is a watertight representation of a set of surfaces. And then within that solid model, you can assemble various quilts or surfaces together to represent the engineering topology that you want. However, for some complex configurations or configurations where there's not really a lot of sharp feature edges, let's say, we have customers that have some really unique needs and would like, I think, some additional tool sets to help make that part of the process a little bit easier. So the two pathways we're exploring, and we plan to address both, are how do we clean up geometry to get to a watertight state? And then how do we make, once you have that watertight state, how do we make getting to the engineering topology that's appropriate for purpose, how do we make that more seamless and invisible to the user? Okay. So both of those are in the plans for Flashpoint for geometry.
And I'll add, if you have a preference one way or the other, certainly let us know.
Yes.
Because these are the questions that we've been asking, so we'd like to know. Okay, all right. Next question, Mike, for you, Flashpoint and Glyph. Can I access the entire Flashpoint feature set through Glyph?
The short answer is yes. If you'd like more details, you can look at the Glyph documentation. We've mapped things pretty well to how you see it in the GUI. If you have additional questions, reach out and we can guide you.
Okay, I'll expand talking a little bit about some of the features of Flashpoint that make it, I think, a little bit easier in terms of automation, and there's less reliance on Glyph, let's put it that way. And that is, when you set up Flashpoint for the first time, including local resolution filters, which you can use patterns to define your resolution filters for specific groups of surfaces that have a naming convention, for example, you can actually save all of that off to the Pointwise environment file and then load that back into Pointwise and load in a new geometry. And as long as the names of the surfaces are the same, it'll automatically reapply all of the filters that you've specified before. If you never specified any filters, it'll still load in all of your settings for Flashpoint, so you can replay it on another geometry without any scripting. And I've mentioned this to Carolyn a couple of times. When it comes to scripting in Pointwise, obviously you can write a script from scratch, which is the best way to do it. It's the most robust. We have a journaling option, and we've kind of reserved journaling for troubleshooting, for education, so that you can see what glyph commands are being used when you perform certain actions in Pointwise, so that when you're writing a script from scratch, you know kind of maybe where to look in the glyph docs and what commands to use and that kind of thing. What I've noticed, at least on my end, is that as we begin to automate more and more things in Pointwise, journaling itself becomes more robust out of the box. And what I mean by that is, if you're using Flashpoint and you have it set up to automatically generate a surface mesh, and the next step is just building a block around that, let's say, aircraft model using our build far fields tool, and then initializing that, journaling that process only has a handful of commands, because Flashpoint's used to generate the surface mesh, build far field is used to generate the block, and then you're initializing that block. So at least in my mind, I envision over time less reliance on scripting from scratch as more and more tools in Pointwise become, push button. That's just something that I've noticed in my own testing of the code and glyph with this feature set. All right. So here is something specific to some of the algorithms and how they work in Flashpoint. Really good question. How does Flashpoint take edge length sensitivity of a surface into account to automatically increase the resolution around sharp feature edges? Does that information come from the CAD model, like quilts, or are there other measurements? Mike, you were working on this quite a bit. Do you want to elaborate on this?
Right. So yes, the geometry factors into the edge lengths. Even though from your perspective as a user, Flashpoint surface meshing is top down, what we do during Flashpoint surface meshing is really bottom up, and we start with making sure the connectors are in the right places, and that the attributes on the connectors are what the final mesh should be. And so along those edges, we take the input parameters where you've requested some type of edge sizing. We use those edges to determine where there should be TRex grown from them. All that information comes from the geometry, and by analyzing the geometry, what is a convex edge, what is a concave edge, things like that. And then once we've got the connectors all set up correctly, then we build the domains out of those connectors. But yes, it's very much driven by the geometry and the input parameters, the few input parameters that Flashpoint has.
Okay. All right. This is a good one. So Carolyn, you demonstrated in your video this last week how the geometry can, be efficiently resolved using anisotropic stretching. And then Josh demonstrated some isotropic mesh adaptation, which is good because it can occur both on the surface and in the volume. Have there been any efforts to pursue anisotropic mesh adaptation? Are we working on that currently? And maybe Mike, you might be able to answer this question. Is this something that we're currently working on?
Yes, our applied research team has been looking into this and exploring this. So it's not the team that I directly manage, but it has definitely been something on our radar.
Yep. I like this one. This one seems more of a feature request than anything, because I haven't seen it yet. Is there a plan to extend the pattern option to the CAE boundary condition panel? I haven't seen that one yet. Carolyn, have you seen that one?
That's new.
That's a new one.
So that would be no, but we will make sure that we add that to our feature request list, which you know, whether, I don't know if you guys are aware of this, and Mike may speak to this, you know, a little bit later in this talk, but we take our feature request list pretty seriously. We use it heavily in our product lifecycle. So.
Yeah, that's a good one. I like patterns. When we expose that capability in Flashpoint and in the local tab in particular, it certainly makes things a lot more efficient, particularly if you've named your quilts and things like that. So I would like seeing, you know, patterns, you know, available in other commands in Pointwise. The CA boundary condition panel would be a good one. All right. Okay. I love quad dominant meshes. However, I frequently find that my quad dominant meshes often have poorer quality elements, specifically in terms of area ratio. Am I the only one that's noticed this? Is there any work to improve this? I'll start by saying I generate quad dominant meshes quite a bit, and Carolyn, you could probably talk to this as well. You will notice in collision regions, particularly when it comes to like TRex, 2D TRex, that you can get some higher area ratios. Locally backing off the layers helps quite a bit, but we have started working on some things that will improve this. And I think maybe Mike, you can speak to this in the next iteration of Flashpoint. There is a feature or two that targets this specifically, correct?
Correct. Even though we did talk about how Flashpoint for volume meshing is next on our list, in parallel, we are working on enhancements for Flashpoint for surface meshing. We knew that, you know, once it, you know, got out in the wild, that it would be used in ways that we hadn't anticipated, and there were a few things there towards the end that were just not able to make it into 18.4 that we have already been working on, and those, you know, we're calling it, you know, Flashpoint 2 for surface meshing. It's not going to be called that in the product, but just our development effort, kind of the phase 2 of surface meshing for Flashpoint is ongoing and will be in the next version of Pointwise.
Okay, and then a follow-on is there a way to adapt by cell area ratio to improve the quality of the mesh? I believe that is also one of the requested features on the plan for the next iteration or two of Flashpoint. So you'll be seeing something for that as well. The plan from the beginning was always there's a goal. If you go into Flashpoint surface meshing, there's a frame called goals, which right now there's like aspect ratio and growth rate, I think, in there currently. And the plan was always to expand that over time as we gain more control over, you know, the surface meshing process, and in particular being able to specify goals for things like area ratio or max angle, that kind of thing. So you can expect to see control over, you know, quality parameters like that moving forward.
But, you know, there's a comment to be made here just in general, you know, about our development process. You know, we'll put out a release with a new feature like Flashpoint. And for us, we're continually taking in customer feedback and evaluating needs in the community. And we evolve our features. Like each release, you will oftentimes see for our most heavily used features, we are continuing to iterate and improve with every release to try to make those even more appropriate for purpose. So I think that with Flashpoint for surface meshing, you'll continue to see us making tweaks and improvements like this over the next several versions. And you should see that for the remainder of the Flashpoint suite as well.
And that's a good segue into an earlier question, which is how do you decide which features to put in next, and what does that development process look like? So Mike, that one's a good one for you.
So, you know, we've said before, we take input from our customers. We log all wishes in a database so we can keep track of them. If it's a duplicate wish, it gets upvoted. We take this information, this database, and we combine it with our you know, current focus areas of automate, accelerate, and innovate. And then we have kind of a short list of things that we're going to work on next. And then the actual process is that when we've identified a feature, We choose typically 3 people from within Pointwise, but from different departments to work on that feature. They meet regularly and iterate over the design and development of the feature. And then the 3 of us, as part of the feature team, we approve of all of the design and development documents. So we're kind of watching over the whole process to make sure it continues to move along and that we're doing the right things and sufficiently testing these new features.
Okay. All right. Some more questions that are very similar to the ones that we've answered. And then, okay, here's one, a new one. Is it in the plan to extend local parameters in Flashpoint? My understanding, it's only the sizing which can be locally adjusted for right now. The short answer is yes, there is a plan to extend some local parameters in the local tab that you could control as well. Good question.
There's a fine balance. We don't want to expose everything that could be controlled because then it's just overwhelming. So, you know, doing that, exactly. To keep the whole automate Flashpoint philosophy going, it's a fine balance.
Well, you know, and just to reiterate in one of the earlier videos, I believe it was Travis said this, that the intent of Flashpoint is to try to give you some goals for us to achieve. But in the background, we are trying to encapsulate a lot of best practices and experience for you and which knobs to turn and how much to achieve what you want in the end. So, that's why we're also, you know, trying, you know, to strike this balance between what we expose and what we don't expose, because we don't want this to turn into a feature that is only accessible to, you know, the most expert users.
Right, and that's why, you know, from the very beginning, the idea was that not only are we encapsulating our best practices, but at the end of the day, you get a mesh that you can then modify using all of the expert set of tools in Pointwise, you know, to your heart's content. You can tweak any of the parameters on a connector or domain level after the mesh has been created. So you're always going to have those tools at your disposal, but they're not all going to be exposed in Flashpoint. Does Flashpoint make use of TRex? Carolyn, you want to go ahead and answer this? Maybe, and maybe I'll say, like, both on the domain level, but also with what you're working on in 3D.
Yes, extensively. So earlier in one of my answers, I referred to the fact that Flashpoint, it looks for areas of high curvature, and it automatically detects convex sharp feature edges. And when it finds those, it can apply 2D TRex off those boundaries to ensure that the underlying geometry is accurately resolved, and or you have a smooth transition around a sharp feature edge like that, because it's not unusual where you see that kind of sharp feature edge to have a trailing edge on the other side of it, where there are maybe some strict engineering requirements for cell count or distribution. Looking forward for the feature that I'm currently working on for automating volume mesh creation, we're also looking at techniques to automatically detect, you know, what's a wall domain, you know, where do we need to grow, based on some of the inputs you give us, maybe, you know, flow-driven parameters. What type of TRex settings need to be used to give you the boundary layer mesh that you need for your purpose? So.
Okay. Another question. I understand that Flashpoint and Voxels provide a very nice feature set for hybrid LES, but was wondering how they might handle RANs. Are there any examples? That's a good question. I have heard from some of our clients that Voxels in particular and the quad dominant surface meshing make really nice meshes for hybrid RANs LES. But they're also used quite a bit for RANs. And in fact, I'm going to plug a webinar next week that I'll be hosting with our partners over at Flex Compute. We took the NASA CRM model from the 4th AAA drag prediction workshop and basically ran it through the Flashpoint and voxel meshing process and ran a RANs calculation and we will be showing the results of that simulation and looking at accuracy specifically, because there's a ton of data from that workshop. So that'll be a great webinar for you to attend, and you know, an application of these features to a RANS case. Good question. All right. Voxels plus sources is great. I agree with you. Thank you for that comment. I certainly agree. Will Flashpoint always be starting from a database, or is it going to be going, I guess, starting from an existing mesh as well in the future? That's a good question. I know that, I mean, the intent of it was always to start from a database. You need geometry, and right now it's a quilted geometry ready to go. That may be relaxed moving forward with some of the database stuff that we talked about earlier. Starting from an existing mesh is interesting. I know that we've been talking about it actually with Carolyn, your feature for block creation. We've kind of talked about the idea of being able to bring a mesh back in and do certain things with it, but not necessarily starting from a mesh.
Block level, right? But I think this question speaks to maybe a certain desire to bring in a surface mesh, whether it's a Pointwise surface mesh or one from another tool, which, you know, we have customers do all the time, and optimize it for your goals. And I think that's actually a really nice request and desire to be able to do that. And I can certainly see this playing into some of our future discussions about continuing iterations of what we do in Flashpoint.
Right. It might also tie nicely in with the earlier question about STLs, because at the end of the day, an STL is a mesh, and perhaps maybe the feature set overlaps quite a bit for doing something like that. But for the person who asked that question, certainly get in touch with us so that we can talk about that a little bit more in detail, make sure that we understand what exactly it is that you'd like to do. It's a good one. This is a good one. Yeah, and I guess this is a follow-on from the same person. You know, an example of this could be running Flashpoint, doing some manual work, and then reiterating with Flashpoint. And yeah, that's kind of where those discussions internally we've been having have kind of gone. It's something like that as well. So that's good. Thank you for clarifying. Okay, let's see here. Carolyn, this is a good one for you. Where do you see meshing going in the next several years? Just meshing in general.
This is another one of my favorite topics. So I think there's a great deal of really exciting work going on in the meshing community right now. Both our applied research group, myself and my group, we're doing a great deal of advocacy. And we do that through industry workshops, benchmark cases, and we're really trying to help push the envelope on meshing and CFD technologies. So from that perspective, I'll speak to a few of the places that I see meshing headed. First, I see there's a really significant push in learning and understanding more about mesh effects on CFD solutions right now. I think the intent is, you know, from the community's perspective, that if we can finally find a way to quantify these effects, we can reach greater levels of automation in the CFD tool chain, and we can maybe finally get to the point where meshing is largely invisible. Along those lines, I expect mesh adaptation to continue to become more mainstream and used more commonly in CFD workflows and analysis. It's an area where I'm seeing a ton of work right now, and it's all very promising. Howard meshing, that's been around for some time, but in the last few years, I've seen it really maturing, and it's maturing to the point where it's actually being used on complex geometries. I think we'll continue to see it mature and mature to the point that mesh adaptation's at now. And just as an example, we've had some recent work from our applied research team on mixed order HP meshing. And they're already looking at how they can apply techniques like that to very realistic geometries like the NASA high lift common research model. And I'd say the final place I see meshing going in the next several years relates to a push to exascale CFD. So it's the opposite side of the coin from high order meshing. The desire to either model geometries to a greater complexity. So now we want to add all the nuts and bolts and pipes and tubes, or use methodologies like hybrid RANS LES, wall modeled LES simulations. That's continuing to push mesh sizes further and further up. How software, how processes, how computational resources evolve to meet those needs, I think it's going to be quite a challenge in the next several years. But I know several different community groups and research institutions that are pretty heavily involved in exploring that. And I'm looking forward to seeing what they do in the next few years.
Okay.
So.
All right. So a few more questions. Let's see here. Where was it? Mike, and maybe this is a feature request, unless you've heard this one before. Are there any plans to extend Glyph Server to make it easier to talk to Pointwise from other software without going by files, without using files?
Well, I guess easy is a relative term. So, you know, for me, a programmer, it seems like it's already pretty easy, but I would need to know specifics as far as how, you know, you'd want to extend the Glyph server. You know, it is a very generic and general thing that allows, you know, communication from, you know, any programming language that has network sockets. And so it's just a matter of what the pain points are and how we could make that easier. But it is very flexible. So.
Okay. And then there's there's just a question, parallelization question mark. I mean MPI. Mike, maybe you could talk to some of the kind of the parallelization efforts or the performance improvement efforts that are going on right now.
Oh, somebody just opened the door, so you might hear some dog barking. Yeah, so we definitely, you know, Pointwise is already parallel. Some might think that that's not true, but we do have several areas of our code that use multiple threads, is able to process things in parallel. Kind of the next step that we're looking at is improving the performance of 3D TRex and the volume meshing and the opportunities for parallelism there. The opportunities are there, and we just need to take them, implement them. There are some, you know, we've seen parallelism take off in the simulation space when it comes to CFD software, but it's a little bit more difficult to do in the meshing space just because of the connectivity. You're dealing with a mesh as you are building it up, whereas a simulator, the mesh is fixed. So there's just a different set of problems that we can't just kind of take what's been done in the simulation space and apply it in the same way to the meshing space. So there's challenges there, but we like challenges, and we will take them on. And as I said, we're currently working on improving the performance of our 3D TRex algorithm.
Okay. Let's see here. For the NASA CRM mesh webinar next week, is it the full geometry with flaps and slats, or is it simplified with fuselage and wing? That's a good question. It is the wing body tail configuration, so no deployed flaps or slats. It's not in the, it's more like in the cruise configuration, not high lift configuration. How would Flashpoint perform for such a complex geometry? What about mesh quality? What I'll say there is, so long as it's quilted properly and represents your engineering topology, Flashpoint will resolve it the way that it needs to, using our best practices.
Right.
So yeah.
If you have some more specific requirements or guidelines you need to apply to that, that might be something that happens after Flashpoint.
Right.
So.
Yeah, exactly. Like if you're wanting a very specific number of points across a trailing edge, for example, or a very specific wing leading edge spacing, you can do that outside of Flashpoint after an initial surface mesh is created. Again,
Right.
if you load up Flashpoint surface meshing, you'll notice that it's resolving to turning angles, it's resolving to aspect ratio and things like that. Again, using a lot of our best practices, but it doesn't know the difference between an aircraft and a car, right? So if you have very specific things that you need to control, that's where all of our existing tool set comes in handy to allow you to very specifically target your meshing requirements. All right, since Carolyn's here, can't help, gotta ask, is multi-block structured mesh for the upcoming high lift workshop going to be provided despite the complexity of the geometry?
Unfortunately, at this time, we are not going to have a committee supplied structured multi-block set of meshes for the high lift CRM. We do have a group that has very generously agreed to provide a structured overset mesh family for the workshop. And I'm really excited to see what kind of results people are able to get on that.
Okay, all right. Do you have some automated tools to treat saddle points where there are multiple normals coming together? Yes, in fact, 3D TRex now detects those, and it has for some time. So even if you have, I think, full layer set to 1, which effectively disables the multi-normal treatment, it still detects saddle points and will splay off multiple normals from them because it knows that a single normal off of a saddle point won't necessarily result in all positive volume elements. So
it's
that
a very
treatment,
local effect.
yes, it's
so very
local.
local.
Yeah, it'll only happen at those locations. So it's in there today, and it should be doing that for you. All right. Let's see. Are there plans to push more local remeshing of the volume without having to define in advance? That's a really good question. I know that like for optimization, what we've been doing quite a bit lately is defining the region that you want to remesh. We do have block splitting, which allows you to carve out regions from a volume mesh, but I can't speak specifically to anything that's being developed at this point that allows for local remeshing of the volume. Carolyn or Mike, anything?
No, but I would say I'd be really interested to learn more about what your end goal is with your local remeshing to see if there's something we already have in work that is applicable. I don't know that I have a good enough understanding of what the end goal is right now.
Like if you wanted to put a source and then just refine the block, perhaps that's what you're referring to, but
So
yeah.
Please reach out and provide more details, and we'd love to have a conversation.
Yep, I agree. We've been doing quite a bit of optimization work and have some upcoming marketing events, hopefully in the new year, that we'll be able to showcase some more of that. But in those cases, as we've done in the past, we know the areas of the mesh that we want to modify, and so we'll locally block those currently. But yeah, please share with us some examples and we can take a closer look at that. That's a good question. All right, okay. It looks like the questions have slowed and we're getting close to the end of the hour. So 2 more questions that I have here are, do one for Mike, which is, how has COVID, in the pandemic, impacted the development of Pointwise, if at all?
Well, of course, as you can tell by the background of our webcams, we're all working from home. Meetings have gone virtual. We're working remotely. But Pointwise already had some employees that were working remotely. And so I think we were able to hit the ground running pretty quick and transition to this new way of working. We've dealt with the same kind of Zoom fatigue things that most people have. But internally, I think we've done really well, and we've continued to develop software. And of course, from our customers' perspective, we now have training available that's online. And that can be a big help to our customers. And we've really worked with our customers to try to help them to be to continue to be productive while they've had to deal with COVID in their own ways, whether that's working from home, whatever. So I think it's going fine.
I would second that. All right, Carolyn, Mike mentioned training, so this is a good segue, and we will wrap up with this question. We've talked a lot about Flashpoint, we've talked a lot about different features. So if people want to learn more about Pointwise, what online resources and courses are there available, and what do you have planned moving forward?
Okay, that's also a good question. So right now we have our Pointwise Mesh Foundations course available online, which Mike alluded to. This provides a really great overview and an introduction to how to use the most commonly used commands in Pointwise. A lot of work went into the course. We spent easily over a year taking what we were known for in our 3-day in-person course and changing that into a format and style that worked well online. And since it was released, which was in March, I believe, we've had a really outstanding response to the course. I've kind of been blown away. So if you haven't checked it out yet, please go do that. I think it is of great benefit, and it's on demand. You can take that course anytime you want. So based on all the feedback we got from that, and also because of some of the trends I'm seeing in people wanting to automate their mesh generation a little bit more, we have started the process of developing a Glyph scripting course to add to our online training center. And I hope that helps users further leverage automation in their meshing processes. I don't have a release date yet for that. We're in the early stages of it, but I'm hopeful that next year we'll see that released. And in addition to that, we have several other courses queued up that we want to develop, as we get these out, that touch on everything from, say, advanced structured or advanced unstructured meshing, all the way to specialty topics. Let's say something related to voxel meshing. So you should hopefully see these courses rolling out in the next couple of years. I'd say the last thing that we have planned that might be a good resource is, and we don't have a schedule yet, but next year we do have plans to have a couple of live virtual trainings on the new feature sets in Pointwise that you can sign up for and attend. So stay tuned. If you're part of our connector email list, you should get notifications when those go online and are available to sign up for.
All right. Thank you very much, Carolyn. And with that, I'm going to go ahead and close this down for now. I wanted to say thank you to everybody who attended, everybody who asked questions. We had some really great questions today. It's gone on for almost an hour, which is fantastic. We really enjoy talking mesh generation and hearing how you all are using Pointwise or wish to use Pointwise. If you think of anything after this that we did not address, you can always email us. A great email address is letstalk@pointwise.com. Go ahead and send us an email and we'll get back to you. I'm sure you may have questions that you forgot to ask during today's webinar. But anyway, thank you all once again for your time, and keep an eye out for the webinar next week. It's next Tuesday with Flex Compute on the 17th at 10 o'clock in the morning. More information can be found on our website, and we hope to see you there as well. All right, thank you, Carolyn. Thank you, Mike, and we'll see you all later.
See you.